All right, good afternoon. Today what we're going to do is the introduction to how much money you need to save every single year to meet whatever your retirement goals are. Now, most of the time when people do planning, they look at, say, a timeline. And we're 25 years old now. We're going to retire at 65, and we're going to drop dead at 95, right? Rest in peace. Okay. Most of the time when people do planning, they figure out how much money they need to deposit. And so you deposit money every single year to build up to some pot of money that then you can pull money out every single year until you exhaust that fund to pay for your retirement, and the fund is then zero when you're 95, which is your projected life expectancy. Now, most people that do this actually do this the exact opposite way. What we don't want to do is figure out how much money we can deposit right now. What we really want to get to is what is the lifestyle we want in retirement. So the starting point is how much money you need in retirement over here, not how much money we're depositing. And so the easiest way to get to this number is to figure out, in today's dollars, how much money do I need to live the lifestyle I want to. And so we'll hopefully assume your house is paid off, maybe it's not, how much vacationing you want to do, what type of cars, travel, etc., etc. And let's say, for example, in today's dollars, you add that up and you think, hey, I need $65,000 a year to get by on. Well, $65,000 today, there's inflation, and so the dollar amount here is going to be an awful lot more. What we really want to do here is preserve purchasing power. So I want in dollars when I'm 65, the amount of dollars it takes to have the same purchasing power here. And so to get that number, what I'm going to use is future value of $1. So I move this forward, future value of $1. My K number here I'm going to use is the inflation rate. And kind of a standard number for inflation is 3%. Inflation sometimes runs a lot lower, sometimes it runs a lot higher, but 3% for long-term projections is usually pretty good. N equals the number of years from how old I am now until I retire. And so this 25 to 65, my N here is 40. So I'm going to use an N of 40. So I look up on my future value of $1 chart, and I get the factor 3.2620, which equals 212,030. So what I need here every single year is 212,030, year in, year out. Now, $65,000 today and 212,030 adjusted for inflation are the same number. It's going to buy the same stuff. It has the same purchasing power. Economically, financially, these are identical numbers, just separated by a number of years and what the inflation rate is, and we've maintained the same purchasing power. So if I want 212,030 every single year in retirement, what does that kind of look like? It looks a lot like an annuity. And so what I'm going to do with this 212,030 is I'm going to back up all these numbers to today. Two things that I need to figure out here. How long am I retired for? So in other words, how long am I going to get this stream of income? And so 65 to 95, N equals 30. And I also need to know how my investments are going to be doing. So we're going to assume over here in retirement, you're going to get an 8% rate of return. So to calculate this dollar amount here, I'm going to take 212,030 times, that's an annuity. We are moving back in time, so we're moving back closer to the present. So I'm going to use present value of an annuity, K equals 8. And we'll get into why we're using 8 later on. N equals 30. So I look up that factor, and that number is 11.2578, getting me 2,386,991. So what that is telling me is that this pot of money that I need to hit to live the lifestyle I want to live in retirement needs to be 2,386,991. Okay? So that's the magic pot of money that I need to hit. Then what we need to do is figure out how much money we need to deposit every single year. Normally when we've done this equation, and we've certainly done it a lot in the past, is we've taken the dollars here that we're depositing and we multiply that by the future value of an annuity to get whatever this magic pot of money is. But that's not what we have right now. What we have and what is unknown is how much money we need each year. So what we have here is our dollar amount that we have times future value of an annuity. We're going to use a K equals 10, which is the average of the stock market. K equals 10, N equals 40. And those factors coming together, multiplying how much you're going to deposit every single year times future value of annuity, K equals 10, N equals 40, gives us how much money we're going to end up having. But I know this answer. This answer is 2,386,991. 2,386,991. So now what we have to do is we have to somehow figure out what this number is. And if we remember back to fourth grade and our basic algebra, what I'm going to do with this is I'm going to divide both sides by future value of an annuity, K equals 10, N equals 40, and this side by future value of an annuity, K equals 10, N equals 40. These two are going to cancel each other out. And so now I've got my basic formula for doing, if you remember, isolating x or solving for x, if we remember back. So this is going to equal how much dollars I need every single year. And so we look up the future value of an annuity, K equals 10, N equals 40, and that factor is 442.59, which gets us a number of each year we need to save $5,393. So each year I need to save $53.93. So right around $450 or so. If we wanted a monthly, we just divide that by 12. Which at first you look at this and you're going, wow, this number is just not doable. I just can't get there from here. But if you have time, $5,000 a year isn't that big of a number. And if we go back to the formulas that we've done quite a bit, if I deposit $5,393 times future value of an annuity, K equals 10, N equals 10, times 442.59, then we're going to get our number 2,386,991. Okay, so that balances out. One of the other things I want to talk about here real quick in kind of the basic introduction is an awful lot of people aren't going to be starting from scratch. In other words, we already have some money invested in our 401k, in our retirement, or something like that. If, let's say you know you're going to end up with a pension of, say, $62,000 a year when you retire, then what we're going to do is make the adjustment over here, and I'm going to take 212,030 minus 62,000, if that's what I'm told my pension is going to be, gets me 150,030. Then I'll back up the 150,030 times present value of an annuity, K equals 8, N equals 30, and we'll certainly have a much smaller number here because our shortfall is $150,000 a year. We've already kind of got 62,000 locked up in our pension. The other thing I might have is I might already have some money saved. Maybe at 25, you've already saved $25,000. So not only do we have the annuity amount that we need here, we're going to go back and assume we still need 212,030, but I've already got a lump sum that's going to grow over time. And so as this number grows, we're going to already have some of that dollar amount. So what I'm going to do here is take 25,000 times future value of $1. So we're not using annuity because this is the base amount of money that I have saved up. I'm not saving $25,000 each and every year. I've got $25,000 in my retirement account, and I'm going to let it run. And I'm going to let it run for 40 years. At 10%. K equals 10. So we looked that factor up. Future value of $1, K equals 10, N equals 40, is 45.259. We multiply 25,000 times 45.259, gives us $1,131,475. And so this money that we've already set aside 40 years from now, which is a long time. I mean, that's really going to have a lot of growth to it. 30 years, this number is going to be half that. So if this is going to grow to 1.1 million, and my target number here is 2.3 million, then what I'm going to do is I'm going to take 2,386,991 and subtract 1,131,475, the amount of money that I'm going to save up, and then I'm going to get what my shortfall is going to be for this number. So I'm going to end up short 1,516,516. And so this 25,000 is going to get me almost halfway there, but I still need to come up with another 1.25 million. So I'm going to take that here as basically my target number, 1,255,516. Get my commas in there, correct? And then I'm going to take my shortfall number and do the exact same thing I did over here. So I'm going to take this number and I'm going to divide it by future value of an annuity. So 1,255,516 divided by 442.59. Future value of an annuity, K equals 10. That's how much we're going to earn. N equals 40. And we're going to end up with a dollar amount of $2,837. So now each year, I need to save $2,837. Our $25,000 is going to grow to be 1.13 million. our $2,837 a year for deposited for 40 years is going to grow to be $1.255 million. We add these two together and we hit our ultimate target goal, which was the present value of an annuity backing up 212 each year of $2,386,991. That's what that is if we add these two items together. So 1, 2, 5, 5, 5, 1, 6 gets us to 2,386,991. And so this is really important to know how to adjust for money you already have in your savings, because really there's only one point in your life where you're going to have nothing hopefully in your 401k account and you're doing this type of calculation. So these are going to change throughout the years because this number is going to go up and down. So maybe later on, when you're 35 or 45, maybe you're 45 years old and you've got $97,000 saved. Well, then we need to go through the exact same process we did before, but the distance here, if you're 45 to 65, is 20. So I'm going to take my $97,000 that's sitting in my savings account times future value of $1, K equals 10, N equals 20, if we've saved this at 45. All right, because N equals 40 is over here if you're 25 years old. If I'm 45, then my N's going to be 20. That's the distance to 65. All right. So in this point, I would then take the 97,000 times future value of $1, K equals 10, N equals 20, figure out what that number is, subtract it from our 2.38 million number to figure out the shortfall, and then go through the same process again and divide into that number future value of an annuity. All right. So hopefully that gives you a good overview of what we're trying to accomplish. And then the next portion of this is going to go over some more math and do some more iterations of it. All right. Thank you very much.